Today we will be talking about BCD to 7 segment display. This is the very important part of digital electronics, and whenever we are talking about 7 segment display, you need to understand that there are 7 segments which actually make up of this display. This display has been quite used in wristwatches and displays over the board where you need to show the scorecard in cricket, and in various digital communication devices where we have been using a simple display, where we need a very simple display and a numeric number needs to be displayed over a particular board. So this particular decoder actually translates there will be 4 inputs available to us, and they will be denoted as A, B, C and D, and these 4 inputs are in BCD. So binary coded decimal input were used as an inputs, and the output will be a simple 8 decoder. Now 3x8, whenever we are talking about the 3x8 decoder, 3x8 decoder will actually produce the 4 output. So right now when we are using the 4 inputs, the 4 inputs are available to us. So we will be using 4x16 or specific decoder, the specific decoder for this particular purpose. Now this decoder is basically a 4x16 decoder, but the information which is actually translated from this part to this part is quite different. Now there are 8 outputs available to us. As you can see, A, B, C, D, E, F, G, H. 8 outputs are available to us, and these 8 outputs are actually gives us the glimpse of this 7 segment display. Now let's talk about it. Now if you are talking about any number, or a letter from 0 to 9, it will be comprises of various fragments, where each and every fragment will actually build up and show a particular number. Let us suppose we want to show a 0 number. Here, this input, if we want to say that this input is available like this, so if this input is on, this input is on, this input is on, this input is on, all the inputs are on, then this number particular will be shown like number 8, numeric number 8. As we want to see a 0 number is quite useful in BCD. So if we want to actually show 0 number, so what is the possibility that this particular number will be available to us? Now let us see. If you want to say 0, so this particular segment needs to be off, other needs to be on the higher side. So logical high output will be provided to all these outputs, but to this output the output will be 0. So to show this number, we can say, so this number will be shown as 1 1 1 1 1 1 and 0. G will become 0. To show 1, we need only this part. So B and C will be on the logical high, others will be on logical 0. That is how you are going to make. So B and C will be on the logical high, others will be 0. Again, if you want to say the 3, so 3 will be visible only if A, B, C, D and G are logical high, others are on the logical 0. Same way, A, B, C, D and G are logical high. A, B, C, D and G are on the logical high, others are logical 0. So E and F will be logical 0, and so on. To show number 9, if you want to show number 9, this needs to be shown like this. So E will be put off. So logical 0 will be provided to E, and others will be on the higher side. So 1 1 1 1 0 1 1. So this is how you are going to make a particular BCD number shown by this. A to F can be shown again by this number 2. So this is a very simple representation of BCD to 7 segment display decoder. Now, when we are talking about, if you want to actually understand what is the meaning of all of this, so you need to understand a Boolean function. As we have already understood that Boolean function needs to be derived from the K-map. So after going through the K-map and each and every segment, you will get A as B bar, D bar plus BD plus CD plus A. Same way, B will come as B bar plus C bar D bar plus CD. C will come as B plus C bar plus D, and that is B bar C D bar whole bar. D will come as B bar D bar plus C D bar plus B bar C plus B C bar D. E will come as B bar D bar plus C D bar. F will come as A plus C bar D bar plus B C bar plus B D bar, and G will come as A plus B C bar plus B bar C plus C D bar. So this is how you are going to understand a various numbers. So this is how you are going to make any number. If you want to understand which number will be visible and which particular segment will be shown, you just need to understand that this is how it will be made. A, B, C, D, E, F, and the middle one is denoted as G. So whenever you want to implement a particular number, you just need to understand that particular number will be made up of these segments. Like 0, if you're talking about the 0, it will be made like this. If you're talking about 2, 2 will be shown like this. It's quite simple. If 3, if you want to see a 3 number 3, numeric 3, it will be shown like this. So this is how you are going to implement the BCD to 7 segment display decoder. So this decoder has been quite frequently used in various digital devices, and this is how you are going to implement this particular circuit. So every now and then when we are talking about a combination logic circuit, what you need to understand is their inputs, their outputs, the logics, the truth table, and after the truth table you need to derive a function, a Boolean function by which you can understand that how a particular thing or particular output can be derived from that particular inputs. So this is how you are going to do it, and this is how you are going to make it. Now if you want to see, you can make any number out of it. It's quite simple, just go with it. I will zoom in for this so that you will understand that various processes available to us. As you can see, the various numbers are represented, and this is how each and every output has been shown. In this particular decoder function, you will understand that various parts, various segments actually give us the actual output. That's all for this particular topic. The next topic is demultiplexer, and demultiplexer are those devices which actually works just the opposite of those multiplexers.